Hello everyone, welcome to this video. In this video we are going to talk about stepwise regression. And so stepwise regression is really an exploratory procedure which helps us find the best model using a set of predictors. So here we have an outcome variable that we are trying to predict, that is substance use, and we have a set of predictors, and we don't really have a strong hypothesis as to which set of predictors is the best when it comes to predicting substance use. And so what we are going to do is we're going to use a stepwise procedure that is going to add predictors one by one, or we can also do the opposite, remove predictors one by one, until we end up with what we think at least will be the best model to predict substance use. Alright, so to do that we need to go into Analyze, Regression, Linear, right? And so we're going to use substance use as our dependent variable, and we're going to use all here our predictors. We don't necessarily need to use them all, but here we're going to ask SPSS basically to try adding predictors one by one up to a certain level where adding a new predictor will not significantly improve the model. Right? So that process is also known as forward stepwise regression, whereas backwards regression does the opposite. It starts with a full model and reduces it, right? Removes predictors one by one. Okay, so what we need to do here is select a different method than the enter method, also called the direct entry method. Instead of testing the whole model and comparing it with a null model that has no predictor, that is just a mean model, we are going to do that stepwise procedure. So there are different procedures that have slight differences. The easiest to understand are the forward and backward. The stepwise notably does something that at each step it also goes tries to go backwards and see if that changes something. So it's sort of a bi-directional procedure, which often leads to slightly better results. Whereas the backwards really removes predictors one by one, and the forward really adds predictors one by one. So these two are slightly more understandable, but this one usually leads to better results. So let's click on the stepwise method. Okay, and that is basically it. One thing that we may want to have in the statistics is we want to check that we have the R-squared change, which is going to show us basically the delta R-square, to compare the different models one with the other. And let's now click on OK and see what happens. Okay, so here it tells me what variable has been entered at each step. And so here it has entered new variables at each step, but you see not all of them. It's not very readable, but we see it here. The first model that was created only included depression. That explained 34% of the variance. And then we included on top of that age, that explained 39% of the variance. Right? So we explained 4% more of the variance. That's the R-squared change. That's a significant amount. And then we added stress due to medical accountability for a total share of variance explained of 42.5%. Right? And so that's a little less than 4% more explained by the model. But that's a significant amount. So here, basically in this procedure, we added predictors, right? And we only could go up to this model, right? Which is not a full model, right? Because we could add other predictors to that. We add actually other predictors in our menu, right? That we added. But if we added another predictor, that would not significantly improve model fit. So we decided to stop there, and from this quite exploratory procedure, we can say that the best subset of predictors is composed of depression, age, and stress due to medical accountability when it comes to predicting substance use, at least in this data set, of course. Right, and so here we have additional statistics. We have notably the ANOVA tables for all the three models. So obviously this is our end model, which is the one that basically we would interpret. And here, same thing, we have the coefficients for all three models here separated. Right, well, we've seen all there is to see for stepwise regression, and I hope you enjoyed this video.